First of all, thank you very much for coming. I appreciate you being here today. And the discussion this morning is about experiences with distribution smart grid implementations using advanced communications. There's two principal speakers. I'm pleased to announce John Suda from CenterPoint Energy and Yan-Pei Chow from Trilliant Communications.
Good morning. My name is Jonathan Sudduth. I'm a project engineer at CenterPoint. Who is CenterPoint Energy? We're based out of Houston, Texas. We're an electric and gas utility. We have gas in various states. However, our electric footprint is only the Houston metropolitan area. What makes us quite unique is we're a very, very dense area. We're serving the fourth largest city in the United States. We have about 2.2 million meters in our service territory, and our peak demand that we're seeing is about 16.4 gigawatts. So it's a lot of power used in a very small area. The Texas market's very unique in the sense that we're deregulated. So CenterPoint is actually everything in green. This is actually green. We own the transmission distribution lines. It's been separated into power generation, T&D, and retail electric providers. So we have dozens of retail electric providers to choose power from for a competitive market. However, we are actually regulated. We own and maintain, we deliver power to the customers, and we read the meters and hook up new customers. Of the electric bill that the consumers actually receive, we have a standard rate on there, which is 20 to 37% depending on their charge per kilowatt hour. A little bit about CenterPoint's smart grid vision is it consists of a few major areas. Our first deployment was starting with the smart meter. Back in, I believe we started that back in 2009. It's a two-way communication to all meters. You can do remote disconnects as well as remote reads. Then starting in 2010, we received DOE funding that actually accelerated that project from completion of 2014 to mid-2012, and also helped kickstart our Intelligent Grid project, which consists of distribution automation as well as substation upgrades and an advanced distribution management system, which includes a DSCADA system. Both of these together actually help enable expanded energy resources such as microgrids, plug-in electric hybrids, distribution generation, and things of that nature, which all is central to the customer. As of today, we have over 1.2 million meters deployed. Since we're focusing more on the distribution automation and intelligent grid portion today, we have actually, I think we're actually hitting about 100 distribution automation switches this week that are actually communicating back. In substations, we've completed 6 substation upgrades, and we have 12 power transformer monitors installed on substation transformers. We'd like to stress that the customer is very, very central to what we're doing, because without the customer, none of this is possible. We have to have complete customer buy-in. We want them involved. We also try to supply plenty of information to the customer, insight into their electric bill, instead of them just receiving, hey, here's your electric bill, this is what it costs. Well, what can they do to reduce their costs? And we've actually kind of coined a term for that, energy insight. We actually have it up in the top corner. It's all central to the customer. One thing that makes this fairly unique as well for the smart grid deployment is we're focusing more on reliability rather than demand management and volt-var control. So again, it's actually trying to keep as many customers on as possible. One key to our success was, rather than actually just using business units throughout the company to deploy, we actually made a separate organization solely for this project. So it's actually governed by a program management office, which oversees various work streams throughout the project, and every person in here is actually a dedicated full-time employee for the project. A little overview of our deployment plan for Intelligent Grid. We started in 2010. We also plan finishing in 2013. We received DOE funding. We're one of 6 investor-owned utilities in the United States that actually received the full $200 million. This is a map of the inner loop of Houston. It's a pretty good eclectic mix of our service territory. It includes hospitals, high-income, low-income housing, the ship channel, industrial, and so it's kind of a good mix. It's only 15% of our service area, but it's a good place to start for phase 1 of our Intelligent Grid deployment. We're also seeking funds after this project to actually expand outside the full service territory. But for the project, it's 579 distribution automation devices on 226 circuits. as well as 29 substation upgrades. If we were to expand outside this, we have about 1,300 overhead circuits, so it's 3,000 to 4,000 devices, and well over 200 subs. Another thing is our design. When trying to implement a successful smart grid project, we first need to decide what is our base design, what are we trying to accomplish. We decided that we want to be able to detect faults, isolate and restore power as quickly as possible, keeping as many customers on as we can, and reducing our SAIDI. And we do this through intelligent grid switching devices, which we've coined as IGSDs, an advanced distribution management system, as well as substation upgrades, and also a reliable communication system. During our selection process, a lot of things that we took in consideration is one, minimal customization and interoperability. So we don't want homebrew applications, proprietary protocols. We want everything to be standard across the industry, because if we're doing something that no one else is doing, we're doing something wrong. We want to be able to future-proof this as much as possible. And then in terms of the selection process for an IGSD, instead of going with a remote control pull-top switch, we also decided to go with a recloser, which helps improve reliability, more mechanical operations, so we're not increasing the amount of maintenance we're having to do in the system. With the communication system, we've actually tested BPL many years ago and determined that it was not necessarily cost effective for what we're trying to accomplish. The AMS project decided to go with a GE WiMAX 3650 radio, which is basically a point-to-point, 3.65 gigahertz, and with a cell phone backup. Well, since that project was already kicked off, when we decided to implement IG, we decided to leverage the existing infrastructure that was already in place from the AMS project. And then also, in order to maintain a reliable communication system, we've chosen to go with GSM and satellite as our redundant communications for all of our switching devices out in the field. Satellites for more remote locations. And again, here's a time frame. They started in 2009. We started implementing late 2010. And when it comes to implementation, a few key things is stakeholder buy-in. That's very, very important throughout the business units. We actually did a mock-up to make sure all of our operational stakeholders had a chance for input on how we should install these things, what the framing should look like, how we do things. Additionally, inside the cabinet, we worked very, very closely. This is actually an ABB unit. We worked very closely with ABB on designing where the radio placement is. Every unit also has a GPS time clock, as well as a redundant communications path. And this unit is actually not quite done installed, but there's aviation protection on all of them, so every unit has aviation protection. And this is actually a high mount antenna, so we actually, in order to get better communications, some of our antennas are 8 feet above the pole. Another really, really hot topic is security. And I say security not cybersecurity, because it's actually both physical and cybersecurity. One thing we're doing on the physical security side is all cabinets are actually installed about 12 feet up in the air, so it's only accessible by a ladder, which helps reduce chances for theft and breaking into the box. Also, we're using a cyber lock, which you can monitor and log any person that accesses this. It's one of the newer locks that substations started using, so we decided to implement this on our side. In terms of cybersecurity, we do IT security scans on all of our devices and to find and mitigate risks. We also do risk assessments with our IT department. We're also sending all of our units off to a third party to do basically hacker testing and to determine what vulnerabilities there are and what we need to do. And we're in the process of currently implementing a plan to mitigate any risks that we found. How we're doing things today is not how we're going to do things tomorrow. So once after the deployment of Smart Grid, it has to be turned over to an operational process. We have a process change team at CenterPoint, which sole purpose is actually to document how we do things today and how we're going to do things tomorrow, actually, and help change the business into what we need to be in the future. Some keys to our success, as I mentioned earlier, product standardization, leveraging infrastructure that we already have, and one really key thing I want to point out is integration and close alignment with all of our project team and vendors. Because without the support, continued support of all of our vendors and making sure that they're there helping us, we have problems, we would not be successful. A few challenges that we face: this is a one-of-a-kind, first-of-a-kind deployment. We're on the bleeding edge. The performance at an operational scale is much, much different than it would be in a test environment. So these are some things that you don't really find out until you're actually deploying. One thing about the performance at operational scale is actually volume of data. You know, when you have 2.2 million meters installed, 600 devices, the amount of information you're sending back to a central location is phenomenal. And how to deal with that, how to route, and where to store this information is a definite challenge. Knowledge transfer, not actually retirees going to younger employees, but actually from a vendor to a CMP project employee, and then from the project to the operational employee. So actually transferring the knowledge from organization to organization is a challenge. Again, as I mentioned, business transformation, because we're changing the way we're doing things. The industry is completely changing. What we do today is not what we're doing 10 years from now. Smart grid is a project now, but 10 years from now, it's just going to be part of our standard operating procedure. And as I've mentioned a few times, stakeholder management. Continual stakeholder buy-in is very, very important. It's impossible to be successful without full stakeholder buy-in. Early 2009, we started deploying our smart meters. We're already in beta testing of home area network devices for the end users, which is our customer insight part, smart appliances, and we've also started implementing intelligent grid. During our next phase is more of a customer engagement, which includes price and load control, electric vehicles to plug in, to feed back into the grid, storage. Our last is making the customer a co-creator of value. So we're talking about microgrids, advanced self-healing grid, and aggregated demand management. So if you have a lot of people throughout the city that have a plug-in electric hybrid that's feeding back, it actually can help reduce your peak demand so we don't have to kick on emergency generation. I'd like to stress that we can't do it alone. These are some of our key vendors that give us continued support and really do help us in our success. This last slide is a slide I'm required to show you by the DOE. It's a legal documentation basically saying they're not responsible for what we're doing even though they're giving us money.
So my name is Yan Pei, and I'm with Trilliant, which is a wireless network provider. So thanks for inviting me to this panel. And thank you, John. Always exciting to hear what people are really doing in the field. So I think for this presentation, I will focus the discussion on how people think about going about deciding for wireless solutions. Just as some background, so Trilliant is actually, again, a wireless equipment provider. So we provide equipment for both AMI and DA applications. And well, I guess I do need to speak a lot of philosophically before I jump into a lot of details. But we actually see a lot of different requirements depending on what the application is. And so, you know, unlike a lot of vendors, we actually first start with the market applications and say, what are the requirements you need? And we find that for AMI, DA, and home area networking, it's actually completely different set of requirements. And so, again, people do use different terminologies. You know, sometimes after you go through the specs, you find out that actually they're talking about the same thing. So rather than use kind of our terminology, I chose to go with the NIST framework, just so that we're on the same page. Okay, and so if you've seen this before, this will be kind of obvious. If not, the areas I'm going to zoom in on are what's known as again, this terminology, wide area network and field area networks. Okay, and again, a lot of vendors use different terminologies, but field area network, depending on the capabilities of what the network can do, most people refer to like an AMI-like system, right? Something that can handle kilobits per second with latencies of maybe hundreds of milliseconds to seconds, right? And it's primarily designed to communicate to meters, right, to field devices, data collection points, and so on, right? Then there's a wide area network, which, again, depending on the vendor, ranges the whole gamma, right? And John talked about the satellite, right? Cellular backhaul, right? In our case, we actually have our own technology, broadband connectivity, right? So again, depending on the vendor, that's very different. But I generally view the wide area network as kind of a bigger pipe, right? More reliable, and it's actually excellent for distribution automation applications for that reason. So I'm trying to share more. I think in the short time, I will give you a sense of how our customers tend to think about how to deploy wireless, okay, and kind of the thought process behind how they kind of make a selection. So again, as a wireless equipment provider, a lot of times, you know, I start with, well, here's what it can do. Look how great it is, right? But sometimes I take a step back and say, well, there's actually a lot of things that I take for granted that we should think through. So even something as simple as wireline as wireless, right? Is that an obvious choice? And I think, let me just state right now that given the choice and if cost is no issue, then ideally you want fiber everywhere, right? The ability to actually have high speed, low latency, wire connection to every single point in your grid that you ever want information from, I mean, that would be nirvana, right? Well, the reality is that will cost so much and the project will take so long, that probably wouldn't happen. And so I think that's actually what drives most utilities to a wireless solution. But now you start talking about wireless, you get into the, well, gee, what are the trade-offs, right, in that selection? And even, in fact, in the last 2 days, on the show floor, having quite a few gentlemen from military come and ask us. I was, again, as a wireless vendor for many years, I'm used to thinking a certain way. But for some of them to just flat out state to me, hey, Yan-Pei, it's wireless. We don't trust wireless, it's unreliable. And I'm like, oh, well, that's a good point. If you're used to having, and to me, frankly, a lot of this perception, right? The fact that when you have a wire connection and something is wrong, you know exactly, in theory, where that wire is, and you know what the connections are, and you have a sense of what to do. It's true, right? Going to a wireless technology where everything is kind of this magic that happens, and gee, if suddenly the throughput halves, you may or may not know what to do. Well, I can see, right? That is certainly a discomfort. Okay, so reliability is definitely paramount on that. But even going through the whole wireless selection, let me just mention a few things that I hear people debate about. And in fact, going through industry, there's a lot of white papers and topics, and it can go endless, but I'll just go through it for your benefit. But one of the debates I hear about is public versus private. Now, should I be using a public infrastructure? The cellular carriers of the world have already spent 15 years deploying their infrastructure, right? They cover 97% of all Americans. Why would I want to go build my own network? And I think fundamentally it comes down to an OPEX versus CAPEX decision, right? I mean, paying the cellular infrastructure, you have all the advantages of, gee, I now don't have to invest in the whole team just to know how to manage this wireless network, right? And I just pay this fee every month, and they manage it for me, right? And I probably have the widest coverage possible, again, because they spend years perfecting their network, right? Well, the drawback is now control, right? The fact that, well, one, I'm paying every single month. So again, depending on your business model, right, there are advantages and disadvantages, right? And we found that many of our customers actually very much prefer a capital expenditure upfront with savings, for the next 20 years, as opposed to this ongoing cost. And of course, a lot of this varies depending on the wireless carrier on your location and how much they're charging, right? So the data plans do matter. So that's one consideration. The other consideration I hear about is, okay, should we do using licensed versus unlicensed band? Okay, and again, sometimes I feel like it gets a little bit too philosophical, but to me, in a nutshell, the benefits of license is that in theory that band is exclusively yours. What does that mean? That means that you put your equipment and you don't have to worry about interference, which in theory means that you can go further and you achieve great range. What's the trade-off? Well, you actually have to go get that frequency. Right? And I wouldn't underestimate what it takes to do that. In most cases, the wireless carriers spend a lot of money getting their licenses, where we all hear about the billion-dollar auctions, right? But even aside from that, certain countries have actually set aside, we will set aside 30 megahertz of frequency for utility usage. Go crazy. Well, sounds great, but then you say, okay, that 30 megahertz in theory sounds plenty for what I need to do, but how many vendors are in that band? Right? And I'm going to generalize a little bit, but you just think about the difference between an equipment manufacturer trying to make equipment for a particular frequency. For example, 1.8 in Canada comes to mind, right? I mean, it's great that this band is dedicated to utilities, but how many vendors, right, given the scale and the number of users that are potentially in that market, how many vendors do you have selling equipment in that band? It's actually not that many, right? I mean, in fact, I personally only know of one company selling WiMAX a year in the 1.8. Right? So just philosophically thinking through it, compare that to buying something, for example, based on, let's just take the extreme, standard Wi-Fi chipsets, right? That even without the energy industry, the wireless companies are shipping, millions of these units every year. Clearly, you get the benefits of economic scale there, right? So again, license or not license, you start thinking, well, gee, of course I want license, right? Gee, I get dedicated bandwidth that's almost as good as wireline connectivity. But then you go through the difficulties of doing that, right? Even if you can just apply for that license, even if it's free, well, you still probably need attorneys who know what they're doing and make sure you don't break FCC rules, right? So that's the second kind of key thing that people think about. The third thing I'll mention is a lot of people talk about frequency bands. Okay, and again, wireless, that's a lot of people, that's like the first inclination to talk about what band do you use? Oh, okay, well this must be better than that just because the physics of lower bandwidth is, lower frequency is better. Well, let me focus you more on the range, right? I mean, really that's what you care about. And why is range matter? It's not so much the whole, oh gee, I can go 2 miles or I can go 3, right? So 3 must be better. It's actually more the amount of equipment you need. So it's just using very simple numbers. Imagine a city of 10 by 10 miles, right? 100 square miles. If you have equipment that goes 1 mile, then it's just simple math. You will roughly need 100 points, right? 100 nodes to cover the whole city. Well, if you can have equipment that can go 10 miles, and I know I'm using extreme numbers, but it's just for the sake of making the point across, then in theory, the tower in the middle can cover the entire 10 by 10, right? So it's actually a total system cost. That's really what you want to think about when deploying a complete wireless system, right? It's not that whole, well, gee, I have better lower frequency band, hence I can penetrate walls and all that great stuff. I mean, that's, to be frank, that's actually marginal. I mean, if you go through the whole range planning, there's actually so many factors, right? Transmit power, how much can you pump through, right? Frequency band is definitely one. Then you have line of sight. I mean, despite all the claims, you really prefer to have line of sight when it comes to wireless and you want reliable links, right? This is not Wi-Fi or cell phones that you can kind of get by if the call gets dropped, right? So having walked you through all those options, let's talk about kind of what some, customer stories are always the best, right? What do people go with? And so I have this one utility that we've been working with ABB, in fact, to sell a joint solution. And this customer is actually, again, listening to John, it's actually so exciting and there's so many things they're doing. But sometimes I forget that not all utilities are moving at that speed, right? Some are really on the cutting edge and they're deploying the latest, greatest technology and they're trying the latest FDIR schemes and it's all wonderful. But then I talk to some who literally have recloses and switches that haven't been touched in 20 years, right? And again, that will actually drive the solution and the type of systems you want to deploy because that actually requires a very different type of expertise, right? So in this particular case, this is actually an island, right? That they actually have zero automation today, okay? And when we, I'm used to numbers, so when I talked to them, kind of my first question was, so what's your kind of SID or FID numbers? What's the passing criteria? What will make this successful? And it was actually much bigger than that, right? It's about, well, right now, the fact that it's on an island, right? Every time there's an outage and we rely on phone calls to find out what happens, I have to dispatch someone there, and there's quite a few key points on the island. So net, it could take 5 or 6 hours to just solve the problem, right? Just being able to cut that down to half an hour will be a huge improvement, right? So in that case, what we decided to do is, and I have to do just a little product talk just to give you the background. But Trilliant has a WAN solution that actually is very high throughput and long range. So we actually go 10 miles. So actually in this case, coverage is actually not a challenge at all. One of our gateways will actually cover the entire island. But for reliability's sake, we actually chose to deploy 2. And on the mainland, they actually have 2 substations that in many ways you look at the map and it's actually kind of perfect for blanketing the entire island. Okay, so we actually designed 2 locations atop existing substations and did the RF studies and decided that, oh yeah, not only can we blanket the entire island, but all the connectors, which is the endpoints, can actually, which have directional antennas by the way, can be positioned such that they can see both gateways. And if one were to go down, you can easily fail over to the other. Okay, so in this initial pilot, there's actually 5 locations, and you actually see the recloser numbers in that system. And then all of this is connected to those 2 substations. And in fact, for fun, we actually also use video. When we share our wireless solution with the end utility, they were actually quite surprised. And again, I take this for granted, but they were very much used to modem speeds, right? So when we start offering multi-megabits per second, they were like, oh, hey, what else can I do with this? And it's true, right? When you have so much bandwidth, in addition to AMI backhaul, in addition to DA traffic, which today is actually still kind of small bandwidth, right? You can actually do the latest video surveillance, right? And they find that very exciting. So all of that actually comes back to a control center, and the black lines you see here, we're using fiber. Okay, and that's fundamentally kind of why they went with this architecture, right? And again, this is I remember asking all these questions about, okay, well, what are your failover time requirements? You know, what are the uptime? And sure, there's all these things in the back of their minds that they're thinking through, but it comes down to today they have zero visibility into what's actually going on the feeder lines in this island. Now, in fact, before we went to talk to them, their plan was to run a fiber line to the island, and this solution will significantly cut down on the cost they will have to spend. Thanks.
And we've worked with many companies. My name is Doug Vogt. I'm from ABB. We've worked with many companies, and as we've gone through the process over the past 2 or 3 years, we've identified that there's generally becoming a trend with a more consistent process. And so I documented the process, and I tried to walk through it as well as I could. The presentation that John made gave you a fairly good idea if you walk through it, where he described how resources changed, how they did the design of the system, how they initiated a deployment, performed testing, and then went to mass installation. So what I've attempted to do here is basically walk through that said that for a utility customer, the idea would be that you would identify what you currently have, what your physical assets are, and that's both human and physical assets, meaning what's the infrastructure that you have inside of your system and what types of personnel do you have. So those are the building blocks that currently exist. Then the intent would be to select an application, and then I gave 3 examples of the applications here. For purposes of this, we'll select fault detection, isolation, restoration, and then establish a project team, develop project goals, collect financial data, produce requests for information, and I'll get into some detail about that in just a moment, assimilate materials to perform the pilot, measure performance to objectives. Once you've done these things, you're going to make discoveries, so you need to correct the weak elements and then finally deploy. This is an example of the process steps that we're seeing that are generally being done. So distribution operations had to do with automated meter reading and mobile dispatching. We're beginning to see that that is being fully deployed, that many utility companies are selecting this area right here and deploying an AMI solution, which means implementing a wireless communication system along with meter systems. And when they're making the choice for the wireless communications, they're generally stepping up now and getting enough data rate to be able to do multiple applications with SmartGrid, including fault detection, isolation, restoration, VoltVAR optimization, security, which is the use of video communications, wireless hotspots for mobile workforce management, and then next will be the asset health monitoring. We believe that that will probably be the next item on the list as they go through the chain of activities. So I listed the points that are right here that are associated with the next steps in distribution automation, and I'm going to talk about those for just a moment. If you go back to my earlier slide, you'll see that it said develop your project goals. So I listed as an example here for fault detection, isolation, restoration objectives, just some examples of some of the goals that an organization might select. Once they've selected their goals, then knowing what the elements are that they had within their infrastructure, and so if their goal was fault detection, isolation, restoration, it classifies as grid reliability. This is the element of SmartGrid, which is within that domain, and then here are all of the various elements that exist within utility infrastructure, and so the selection to do fault detection, isolation, restoration would include automated switches, would include some form of distribution automation, some type of meters, some form of AMI wireless communications, some monitoring, analysis, and controlling software, and then generally some microprocessor protection. So those are the components that would be selected in order to be able to do fault detection, isolation, restoration. You'd look at your total system, and I generally propose that you would deploy a small pilot so that you can identify where the areas of weakness are, make your permanent corrections, and then begin mass deployment. So let's take the area of feeder automation network. For this is the area that you're going to be deploying your fault detection, isolation, restoration. So for purposes of our discussion here today, it would include line reclosers, switch controls, and then ultimately would come back into the substation where there would be a gateway, and then ultimately back into some form of SCADA or DMS. So if you have the components, which is the wireless communications, automated switches, wireless communications interfacing back to gateways, gateways to an operation control center, you can perform multiple types of fault detection, isolation, restoration schemes. You can do simple isolation restoration schemes if you're going to do primarily substation-based circuit switching, if you're going to do mass circuit switching, and you're going to deploy volt-VAR optimization, then it gets a little more complicated, and then generally you would have a coordination between the substation controller, the distributed controller, or the gateway as it's described here, and the control center system that you see, which is represented as the SCADA DMS. That concludes our presentation.